Good afternoon, Isabel. How are you doing this afternoon? I am doing well. It's been a lot better than this morning. This morning when I woke up, um, I had classes of 120 that only 5 students were still enrolled in them. Something was really messed up with Blackboard this morning, but everything got fixed, so things are okay. Um, let's get going. Today, the fundamental theorem of calculus part 1 is super easy. But some of the some of the free response questions I've taken. Second semester we do a lot of problems that are uh, off of previous AP tests, and the two that are on tonight or on the assessment this week, they're pretty tough. We are going to do one of them in class today. I tried to do one of them by myself this afternoon, and I did not get the answer that the AP test form came up with. Um, and hopefully you can help me find where my error is, because I was struggling with that one for quite some time today. It's like, the answer just does not make sense to me. Okay, let's get going. This week we are doing the fundamental theorem of calculus part 1. Now, next week, the fundamental calculus part 2 is the biggie. It is what all of second semester is going to deal with. So do not miss next week, because it is the most important one. And next week is Valentine's Day on Monday. That's crazy. All right. So the fundamental theorem of calculus part 1, it says, if f is continuous on AB, then the function capital F of x is equal to the integral from a to x f of t dt. Has a derivative at every point x in AB, and df dx is equal to d dx of the integral, blah, 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 blah. What does that say? What it's saying is, if you take the derivative of an integral, you just get the function back. That's all it's saying. So this is the original function. So if we take the derivative of this, we end up with the derivative of the integral, which crosses off, which just leaves you with f of t. Now, doesn't make much sense. And it will not make much sense until next week. As I said, the fundamental theorem of calculus part 1, I really shouldn't even teach, because it really doesn't have any effect on the problems, but it's in the textbook, so we have to go through it. So what they're really saying is, if you take the derivative of the integral, all you're left with is this. So if you have an integral from 0 to x, all you're doing tonight is you just put x in for t, and that's your answer. So my answer here, if I take the derivative of the integral, I end up with 1 over 1 plus x squared. Done. That's it. Pretty easy, hey? Now there are some tougher ones, and the variable has to be on top. Okay, if the variable's not on top, you have to get it on top. Okay, so here's another example. If you're finding the derivative of the integral from negative pi to x, sorry, I don't know why these came out so fuzzy today. All you do is just put x in for the t. So my answer is cosine, oops, I was going to write cosine of t, cosine of x. Done. That's it. Just put that value in for t. Boom. And we're done. And basically what they're saying is, if you take the derivative of an integral, it just crosses each other out. Here, well, that's the answer of that last one. I think this was the one that we did before. So we just put the x in here. So my answer is just 1 over 1 plus x squared. Done. Now, let's say there's anything but an x. Now we have to use what's called the chain rule on this. So if this up here is anything but an x, if it's an x squared or a 3x to the 4th or whatever, we still have to plug it in for t. So this would be cosine of x squared times the derivative of this. So my answer would be 2x cosine of x squared. Done. That's it. And that's one of the harder ones when the integral is to something other than an x. And there's the answer. All right. So I'm going to let you do this problem. It says if f of x is equal to the integral from 1 to x squared of the square root of 1 plus t to the third dt, then what is f prime of x? So basically they're asking for what is a derivative of that integral. So your answer would be, and you can just say A, B, C, D, or E on there. Letter A is correct, right? Because if you put x squared in here, we end up with the square root of 1 plus x squared to the third. And then this is not an x, so I have to take the derivative of it. So that's 2x. Well, x squared to the third is just 6x, so I'm left with 1 plus, I'm left with 2x, the square root of 1 plus x to the 6th power. All right, so those are fairly easy. How about this one? Now the x is on the bottom. How do I get it to be on the top? Okay, how would you get that to be on the top? Reverse it. Yeah, and how do you reverse? You got to put a negative in front of it. So in this problem, I would just put negative, and then integral from 5 to x of 3t sine of t, and then I just put the x in there, so it's going to be negative 3x sine of x. Now this one is kind of interesting because it doesn't have a number on the bottom. It has two variables. So what I always tell kids to do when you have something like that, I just tell them to make a number line. Okay, so I've got 2x here, I got x squared here. You can put any number in here. It really doesn't make any difference. I always put just 0 in there. And then I do the integral from 0 to x squared plus the integral, well, we're reading it from left to right. I could have started off with 2x. So this would be 2x to 0 because you're going from here to here. So let me start that one over. I'll do it a way that makes a little bit more sense. Okay, so in this one, I do my so I just have 2x to x squared, and then I just put any number in here. You could put 5, you could put 10, you could put any number you want in there. It makes no difference. And then I just do the integral from left to right. So I have the integral from 2x to 0 plus the integral from 0 to x squared. Okay, of this thing, I mean, it's 1 over 2 plus e to the t, 1 over 2 plus e to the t. Okay, so the problem with this is that the variable's on the bottom, so I have to rewrite it. So I'm going to go negative 0 to 2x, 1 over 2 plus e to the t, plus the integral from 0 to x squared of 1 over 2 plus e to the t. So now I just have to figure them both out. So I'm just going to put an 2x in for t. So that gives me negative 1 over 2 plus e to the 2x. But remember, since this is more than just an x, I have to take the derivative of that. And well, that's 2. So I'm just going to put that over 2 plus, and then I do the same thing here. I put an x squared in there. So that's 1 over 2 plus e to the x squared, but that's more than an x, so I have to take the derivative of that, so that's 2x. And I'm just going to put that on top. So that would be the answer for that one. Now, that's a pretty tough one, no question about it. But you just have to remember to just break up the interval and then work it out piece by piece. And as I said, you can put any number in here. It really doesn't matter. I could have put a 10 in here because the number doesn't do anything to the problem at all. And that's why I usually just put 0 in there. Okay, does that make sense? All right, so that's the first part of tonight's assessment. dealing with that. I think this is the answer that they did the work. So there's the answer. Now the second part is the hard part. This is the part where you have to understand what this is doing. There is always a problem on the AP test that gives you something like this. And they tell you exactly what g of x is equal to, okay? And then they'll give you the function and they'll give you the graph. What you have to realize is this is always going to be the derivative graph. Anytime they have it written out like this is the derivative graph, and then, you know, sometimes, you know, they'll have it starts at 10 or something like that, and we'll get into some of those problems, but not this week. That's where it gets a little bit more complex. But what I want to do is I want to show you what type of problem is always on an AP test. This problem was on 2014. Every year there is a problem like this. Now, I think there's another part to this, because all free response questions on the AP test are worth 9 points. Okay? What you are trying to do, because you're not going to get all 9 points on every problem. There will be some problems that you'll get all 9 points on, but then there will be some problems that you get 0 points on. What you have to do is you have to try to average 5 points on all of the free response questions. If you can average 5 points, you will get a 5 on the AP test. That's how it always works. So so sometimes you look at a problem and say, man, I don't get this thing. Try to do as much as you possibly can. So for example, in this problem, it gives us this graph. So right away, I know this is going to be a derivative graph. I'm probably going to have to look for the areas underneath this thing. But then they tell me what g of x is equal to, okay? They tell me that g of x is equal to, I got to get my marker out here. They tell me g of x is equal to the integral from -3 to x. So this is really important. It starts at -3 to x. And then they ask us to find g of 3. Okay. So what you have to do is you have to use what they gave you. They give us this. They're saying that they want us to find g of 3. So we're going to put 3 in for x. So we really have to, if you're thinking about it, they want us to find the area underneath the curve from -3 to 3. So can we do that? Okay, well, -3 is right here. +3 is right here. I need to find the area. So if I take this all the way down here, looks like it goes to about there. Okay, so remember, the area above the x-axis is positive. The area below the x-axis is negative. So 1, 2, 3, 4, 5. So the base of this triangle is 5. The height is 1, 2, 3, 4. So base times height divided by 2. So this is going to be 10 inside here. Okay, so I've got 10 minus, because this is an area below the x-axis, right? So I'm looking at this thing and I'm thinking, okay, how am I going to find the area below that? Well, same thing. Isn't that, it looks like the height here is 2. Okay, so 1 times 2 is 2, divided by 2 is 1. So I'm going to say that g of 3 is equal to 9. All right. Any questions on that? And usually they, you have to use this information in order to get some more information. We'll see if we have to or not. Because they're telling me that g of x is equal to the integral of f of t. Well, this is f of t. They told me that the function f is defined on the closed interval. The graph of f consists of 3 line segments. This is f. In order to find g, they're giving us a definition. They're telling us that g of, so we could find anything. If I asked you to find g of -3. You could use this function to find that. Well, this function goes along with this graph. So what if I asked you to find g of -3, what would you say the answer would be? Correct. Because, and that's one of the cool questions that they could ask, because if you put -3 in here, you've got an integral from -3 to -3, which we learned last week is 0. But I could ask you any value in between -5 and 4. So I could ask you, I could say, okay, what is g of 0? You should be able to use this function to find any one of those. So if I wanted to find g of 0, I have to take the integral from -3 to 0. This is my x value, but this is how they defined it. They defined all of the g values equals, the area, basically the area underneath the curve from -3 to whatever value you go to. That's what they're saying, is that's how you find that value. So if I wanted to find g of -3, 1, 2, 3, so this is 3, this is up 4, so that would be 6. G of 0 is equal to 6. Okay, so that is how they define the problem. So this really is the derivative graph. All right. So now it says, on what open intervals between -5 and 4 is the graph of g both increasing and concave down? Oh, this goes back to last semester. When does a derivative graph, when is it increasing and concave down? So what interval would that be? I think you struggled with these during first semester, if my recollection is correct. Now you're looking, yes. So this is going to be the derivative graph. So when they're asking you about anything about g, you're looking at this function. So when is it increasing? Anytime it's above the x-axis. Okay. When is it concave down? Anytime the slope is negative. So there's going to be two intervals here. Between -5 and -3, that function is increasing because it's above the x-axis. Yes. Well, no, you're not looking at it correctly. This is the f graph. They're defining g by this function. F of t is the derivative. This is the derivative graph. So what they're asking us to find, they're not asking us to find g prime, but that's what it's defined as. G of x is defined as this. Remember, the integral is really the opposite of the derivative. So the integral of dt is just crossing everything out. So this is the derivative graph. So, you're thinking too much. Anytime they give you a function like this, this is the derivative graph. Anything they ask me about g is off of this graph. So, and this is the derivative graph. So if they're asking me where is it increasing? Well, it's increasing between -5 and 2 because it's above the x-axis. Where is it decreasing? Well, between 2 and 4. It's below the x-axis. Well, the question was, where is it increasing and concave down? Well, concavity is the second derivative, and that tells us if it's concave down, it has to have negative slope. Well, this has negative slope, and it's above the x-axis, so it's increasing and concave down between -5 and -3. It's also, let me change the colors. It's also above the x-axis, so it's increasing, but it has negative slope here also. So that means it's increasing and concave down between 0 and 2 also. So there are two places on this graph of g of x that it's increasing and concave down. And that goes back to first semester, being able to look at a graph and tell where is it increasing, where is it decreasing, where is it concave up, where is it concave down. Those are, any places it's above the x-axis, it's increasing. Any places below the x-axis, it's decreasing. Concavity is the slope of the derivative graph. So negative slope, concave down. Positive slope, concave up. Now, part C is going to blow your mind. Okay. Part C deals with, now it says let h of x equal g of x over 5x. And it wants us to find h prime of 3. Whew. H prime of 3. Wow. So, what do you need in order to find h prime of 3? You need the derivative, don't you? So in this problem, g of x is the derivative of f. But when you put an integral in here, it's just saying, hey, if I take the derivative of an integral, it's just the f of x. You're thinking too hard. You're making this way too hard. This is the derivative graph. This is f prime of x. Once you put an integral in it, that means it's g of x. That's all there's to it. You're making this, you're trying to make the problem harder than what it is. It is not. I mean, this is, and that's all there, it's just the derivative graph on that function. And you will see, and we'll do the next, so in this next problem here, oops, that's the answer key. Don't want to do that. This is the next problem. This is, I think this was like 2018 or something. Again, and this is the graph of f. Well, once you put it in front of there, that just means that this is the derivative graph. And in order to, and then they're going to tell you, okay, I want h of x to equal this. Everything you get off of this graph is a derivative graph. So tell me where, let's just look at this graph. Where is that graph? This is the derivative graph, okay? It just says graph of f, but it just, when it's in front of that or behind the integral, it just means it's the derivative graph. This is the derivative graph, okay? Where is this graph increasing? Between what values? No, that is not when the derivative graph is increasing. All right, let's go back. Need to get out a separate sheet of paper here. All right. If I give you, oops, this is not a derivative graph. This is a normal graph, okay? I'm just going to graph out a normal function here, all right? Not a derivative graph. This is just y is equal to x squared, all right? That's what my graph looks like. Where is that graph increasing? And remember, this is not a derivative graph. This is just a regular graph. Where is it increasing? No, no, no. This graph is increasing from 0 to infinity. It's going up. When it's going down, it's decreasing. This graph is increasing from 0 to infinity. Where is this graph decreasing? It's decreasing from negative infinity to 0. When a graph is going up, it's increasing. When a graph is going down, it's decreasing. We read graphs from left to right. This is just a normal graph. It's not a derivative graph. It's nothing. It's just a regular graph. Where is this graph concave up? Oh, whenever the slope is positive. Okay, I'll go back to that your last. Oh no, because you said all values. No. Okay, so where is it concave up? And remember, this is just a regular graph. It's not a derivative graph. It has nothing to do with calculus. Yes, this graph is always concave up. All right. I'm going to try another graph here. This is not a derivative graph, just a regular graph. Okay, so this has nothing to do with calculus. I just got to make sure you understand this, because if you don't, it really makes it tough to go through concavity and increasing, decreasing. So let's say, okay, so this is, okay, so let's say I had a graph that looked like this. Though I should have made it a little bit easier to read. Okay. Where is this approximately? Where is this graph increasing? I know, I should have made it a little bit nicer to read. But when you read a graph, you read it from left to right. If it's going up, it's increasing. When it's going down, 2 onwards. Okay, so it's increasing from here forever. Okay, it also is increasing here. It's kind of, so from like -4 to whatever this is, let's say -2, that's increasing. And then let's change colors. In blue, it's decreasing. So all of this is decreasing. So just by looking at a graph, you should be able to tell if it's increasing or decreasing, right? All you have to do is read from left to right. If the graph is going up, it's increasing. If it's going down, it's decreasing, correct? Okay, now, they never give you the original graph. That's the thing about calculus. They're not going to give you the original graph and say, oh, where's it increasing, decreasing? They're going to give you the derivative graph. So I don't know what the derivative graph of this looks like, so I'm not dealing with that. But I do know what the derivative graph of x squared looks like. So I'm going to give you the derivative graph of this, okay? The derivative graph of this looks like this, doesn't it? Because the derivative of x squared is 2x. It's just a linear function. Okay, so now they'll give you this as small f. This would be big F. Anytime you see big F of x, that's the original graph. Small f, derivative graph. Where is this graph increasing? I'm sorry. This is a derivative graph. Just by looking at the derivative graph, where is the original graph increasing? And all you have to do is look at where it's above the x-axis. This is the x-axis. Anytime it's above the x-axis, the original graph is increasing. Whenever it's below the x-axis, the original graph is decreasing. Does that make sense over here? It's decreasing from -infinity to 0. Yes, it's increasing from 0 to infinity. The derivative graph tells me where the original graph is increasing, decreasing. It also tells me concavity. If I have the derivative graph, anytime the slope is positive, the original graph is concave up. If it was negative, if the slope was negative, it would be concave down. Well, this is always positive slope, so I know the original graph was always concave up. Though that is such a huge concept in calculus, by being able to look at a derivative graph and tell me what is happening at the original graph. Now, this point where it crosses the x-axis, that's an important point. It's not an inflection point. It is a max or min. How do I know if it's a max or min? Well, it's decreasing and then it increases. So it's decreasing, then increases. This is a minimum value. Is it a minimum value on the original graph? Yes, it is. So those are the things that you have to be able to look at a derivative graph and tell me what's happening. If you can't do that, the problems for tonight's homework are going to be really tough. So I'm going to give you a graph. I'm going to give you, this is small f of x. That means it's the derivative graph, okay? Should add a piece of graph paper here, but I don't. So I'm just going to make one. All right, so put a point there, point here, one here, here, and here. Okay. All right. This is small f of x. Means it's a derivative graph. Okay. I want to know what's happening on big F of x. So this is the derivative graph. On the original graph, where is it increasing? Where is that function increasing? And you don't know what the original graph looks like. You have no clue, but you should be able to tell me where it's increasing. So where is the original graph increasing? -3 to -1 and 2 to infinity. Correct. Tell me where it's decreasing. Now I'm not. Okay, sorry about that. I ended up with that spinning wheel. Okay, yes, between -1 and 2, it's decreasing. Tell me where it's concave up. So where is the original function concave up? One onwards, -3 to -2. I agree with that. Because, well, nope, 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 I don't. I don't. Ah, yes, I do. I'm sorry. Yes, I do. One, okay, so one on. Okay, so now here's the hard one. Tell me where it's decreasing. Where is the original function decreasing and concave up? So it's decreasing, but it's also concave up. Correct. Yes. It's decreasing because it's below the x-axis. It's concave up because it has positive slope. Yes. All right. I think you've got it. And that really, you really have to understand that, especially when you get into these free response questions, because they're always going to deal with that. Okay, so let's go back to my slides here. All right, so we're on this problem here. All right, so now it says, on what open intervals between -5 and 4 is the graph of G both increasing and concave down? Okay, so increasing means above the x-axis, concave down means negative slope. So I'm going from -5 to -3. And it's also between 0 and 2. Does that make sense, how I came up with those? Okay. So now the hard problem on this one, because these two problems on an AP test, these two problems you should get automatically. Now I know obviously this is the first time we've talked about how to get these, but we'll be doing a lot more of these types of problems before the semester's over. And this one. So those are automatic. Those should be automatics. Usually you'd get about 3 or 4 points off of those two problems. Okay. Now the next problem is a doozy, because it says use the function of h, and then they define h as g of x over 5x to find h prime of 3. Well, if I wanted to find, if this is h of x, I want to find h prime, guess what? I have to take the derivative of this. So what are they trying to figure out? They're trying to figure out, do I know how to do the quotient rule? So u is equal to g of x. U prime is equal to g prime of x. I don't know what the derivative is, but I'm just going to put that down. V is equal to 5x. V prime is equal to 5. Inside, I'm going to change my thing a little bit so it writes smaller. So inside, so I've got 5x times g prime of x minus outside, so that's 5 g of x all over bottom squared. Well, that's 25x squared, isn't it? What am I trying to find? I'm trying to find h prime of 3. So I'm going to put 3 in for x. So I'm going to put 3 here. 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 Okay. 5 times 3, just 15. What is g prime of 3? Ooh, g prime of 3. What is that going to be? Okay. So now before we get to that, let's try to figure out the rest. So we don't know what this is. Minus 5 times g of 3. What is g of 3? Well, guess what? We already found that in part A. Oh, they usually do that. They usually do little tricks like that to see if you were paying attention. So we already know what g of 3 is. It's 9. And then down here, well, I've got 3 squared, that's 9. 25 times 9. What is that? Is that 225? 225, I think. Okay. So now the only thing I don't know is g prime of 3. Well, guess what? This graph here is really going to help us out a lot, because g prime of 3 is just really the derivative at 3. You know, where's 3? 1, 2, 3. Means it's a slope right here. What is the slope right there? Because that would be the derivative of this function. Well, the slope, I think, if I'm not mistaken, so let's see here. So the slope of this line starts way up here at 4, goes down to 2. So isn't that, is that a -2 slope? Let's see here. So that's 0, 4. And what is that point there? That point was 2, 0. Oops, 2, 0. So 0 minus 4 over 2 minus 0. So -4 over 2. So that's -2 slope. So I'm going to say my slope is -2, or g prime is -2. So now it's just, okay, so I've got Negative 30 minus 45 all over 225. What is that? Negative 75 over 225. And then you could simplify it down. I guess, what would that be? Negative 3 over 9? Is that right? Or negative 1/3? Something like that. Now, the next page, I have the values that you would get for each part. I think there was a part D to this problem, but we don't know how to do that just of yet. Okay, so if you take a look at this next, this next slide here, part A, there's only 1 point. Okay, it was only worth 1 point. 9. If you got 9 for an answer, you'd get 1 point. Boom, got it. Part 2 was a pretty easy question. Between -5 and -3 and 0 and 2, you get 2 points there. So now you have a total of 3 points. This was a tough problem. Okay, trying to figure this out. Once you understand how to do it, it's like, it's not that bad. But if you got -1/3, you'd get 3 points here. So now you have a total of 6. I don't know what part D was. I didn't copy it down, but that's 6 points. You already have more points than you need. What did I say? All of them are worth 9 points. All you need to do is average 5 on each one of these free response questions, and you'll get a 5 on the AP test. That's how it works. Well, we've got 6 points here. Now, would have you gotten all 6 in the beginning? Probably not. But this is the first time looking at a problem like this. Okay? The more you see, the more you'll say, oh yeah, that one, I remember the problem like that. All right, now, this is the last problem for tonight. It is a problem on the assessment this week. Okay? This problem is, I think, problem number 3 on the assessment. All right? Whew. So they give us this function, and they say that h of x is equal to the integral from 0 to x f of t. This is f of t. Remember, it's the derivative graph. So what I want you to do is I want you to try to find h prime of 8, h double prime of 6, and h of 8, the derivative at 6, and then the double derivative of 4. So h of 8, h prime of 6, and these are very, as I said, every AP test has a question like this on it. All right. I'm going to give you a couple minutes. Try to see if you can get any one of those. All right. And then I'll walk you through each one. Okay. I know you probably didn't get all of them. 2, -2, and 0. I believe That is correct. Oh, no, part C is not correct. But part A and part B are correct. Yes. Okay, now, when I do a problem like this, h of 8, I just put 8 in here. So I've got the integral from 0 to 8, which means I just have to find the area. This is -1 here. This is 1, 2, 3, 4 by 4. So this is 8 here. And then it goes all the way to 8, right? 8 is what we wanted. So 8 is way over here. So this is a negative. So this is a, I believe this is a trapezoid. So 1, 2, 3. So it's a 3 by 2. So the base 1 plus base 2 times height, divide by 2. So that's 5. So I have -5 down here. So I've got -1 plus -5, that's -6 plus 8, which gives me +2. Awesome. Excellent. Now, the second one, it says h prime of 6. Well, 6 is right here. The y value is -2. That is the derivative. This is the derivative graph. So that's -2. And then h prime of 4, that means at 4, 1, 2, 3, 4, what is the slope? Because now if you're doing a double prime, this is the first derivative graph. So if I want the second derivative, I have to find the slope at that point. So I'd have to find the slope of this line right here. And that slope, so I have 2 points here. I have 3, 4, and let's see here, 6, -2. So -2 minus 4 over 6 minus 3. So that's going to be -6 over 3, which is -2. Looked at x equals 3. All right. So not that difficult of a problem, is it? I mean, when you think about it, it's like, oh, okay, I should be able to get those types of problems. Okay, now, between 0 and 8, take a look at that graph and tell me where there is a maximum value and where there's a minimum value. Okay, so now we're going to go on to part B, but I want you to be able to tell me where max and min are. Okay, where's a maximum? Max and mins always occur where it crosses x-axis, correct? So is this point here a maximum or a minimum? It's a minimum, correct? Very good. So this is a minimum. I know that. What is this point right here? Max. It's correct. Okay. So in the next question, it says, find the values of x at which h has its minimum or maximum on the closed interval between 0 and 7. Okay. So we know we have to check out -1. We have to check out x equals, what is that? 1, 2, 3, 4, 5. We also have to check out the endpoints, 0 and 7. Because a max or min can occur at an endpoint. So now, what I'm going to do, I'm going to do this one first because it's the easy one. I've got the integral from 0 to 0, right? Because that's my x value. What's my answer? 0. Correct. So the value here is 0. And now that could be a minimum value, right? I mean, 0 could be the lowest. So now let's find when x equals, oh, why do I have x equals -1 here? I don't get that. That's +1. I don't know why I wrote -1. I'm sorry. I don't want to mess your head up. That should be +1. So I'm going to do the integral from 0 to 1. What is the value between 0 and 1? Value? No. It's below the x-axis. It's -1, right? If I find the value between 0 and 1, it's all negative. It's -1 down there. So that is my value at x equals 1. If I did the integral from 0 to 1, that should be -1, right? If I did the integral from 0 to 0, that should be 0. If I do the integral from 0 to, what is my next value? 5. What do I get? From 0 to 5. Correct. You're on the right track. Right. So now I'm going from 0 to 5. So this is 1, 2, 3, 4, 5. So what's my value now? From 0 to 5. 7? Is that correct? What is the value up here? 1, 2, 3, 4. So this is 8 up here, right? That's 8. 1, 2, 3, 4. 16, 4. So -1 plus 8, that's 7. I agree with you. Boom, that's 7. Excellent. Okay. And then the last one is between 0 and 7, right? Between 0 and 7. So now, where's 7? 6 is here, 7, so that's 5, 6, 7, so 7 is right here. Okay. So that value would be, what is that one? Between 0 and 7? Now, you really don't even have to find it, to tell you the truth, because you know it's not going to be a minimum. You know it's not going to be a maximum. 4.5? Okay. All right, so now to answer the question. Find the values of x, which h has a minimum. Okay, so the x value would be 1, wouldn't it? That would be my minimum. When x equals 1, the minimum value is -1. What is the maximum? When x equals 5. Yep, my maximum value is 7. That is correct. All right. So those two are done. Now part C, this is the one that I didn't get right. And I don't know why. Maybe you can help me. Okay, so it says write an equation for a line tangent. What two pieces of information do we need in order to write an equation of a tangent line? Yeah, because anytime it says tangent, first two things, point and slope, correct. Okay, so I need point and slope. Well, the point, I know x is 35. I do not know what the y value is. Slope, I don't know what the slope of at 35 is. This graph doesn't go out to 35. This graph only goes out to, what, 16? Is that 16 there? But it says up here that it's a periodic graph. Every value, or every time you go 8 units, it repeats itself. So this is going to go up, down, over. So then that would be at that would be at 24. Then it's going to go up, down, over. So now so this is at 24. So then that would be at 32, right? So it's every 8 it's repeating. But at 35, so really I'm starting back over here, right? If you think about it, so now I'm going to go back up, but how far do I have to go now? Because I'm at 32 already, and I want to get to 35, so I really only have to go 3 more units, right? So I'm just going to go over here, because isn't this when it start over again? So I only have to go to 3. So 1, 2, 3. This is where I'm stopping if you continue that graph out, right? Do you understand what I'm saying? Is that this is it's gonna just repeat here. I'm at 32. Okay, so now what is my point at 35? So this would be 35, comma 4, wouldn't it? Yep. So now I have my point. No, I'm sorry. I have my slope, because that is the slope at any given point, right? So I have my slope. The only thing I don't have is I don't have my point. Well, I could do this. I could do 0 to 35, because that's how I get my point, right? H of x is equal to 0 to 35. Well, if I go to 8, 0 to 8, what's the value? What's the value from 0 to 8? And we already did that. No, 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 no. 0 to 8. You gave me that answer. You look up in your, you already told me what it was. Nope, it's not 3. Because we found that, and you found, yes, it's 2. So this would be 2 plus 2. Because if I did 0 to 16, guess what? I'd have this 2. Then I'd have this 2. Then if I did 0 to 24, I'd have 2 plus 2 plus 2. So 0 to 24 would be 6. Then if I went from 0 to 32, that would be 8, wouldn't it? Because it's just, I'm just keep adding 2 on. Every time I go 8 more out, I'm adding 2 more on. So from 0 to 32, I'm at 8. Because I did 2 plus 2 plus 2 plus 2. I'm at 8. So now I really only have 3 more to go from 0 to 3. And this is where I don't get my answer. Because this is -1 here, isn't it? And so that's 1, 2, 3. So this is 2 by 4. So that area is 8. No, wait, that's 4 minus 1. That would give me an extra 3 to add on, right? So I am saying that the integral from 0 to 35 is, what is it, 11? That's what I'm saying. Do you get what I'm doing there? I'm just adding 2 on every time, and because I need the value at 35. So I said that my point is 35, 11. So now I wrote my equation. I did y minus 11 is equal to 4x minus 35. Done. However, the answer key says 10 right here, and I don't get it. I don't get 10 there. I don't know how they got 10. I get 11. I don't know how they got 10. And it drove me crazy today, because it's like, I get what they're doing. They're just trying to find the value from 0 to 35. But I just don't get 10. I get 11. So I was very confused by the answer key. But I had 11, and I don't get 10. I get 11. So I'm sticking with 11 because it makes sense to me. And I mean, visually I can see it. Mathematically I can see it. I just don't get 10. So, but this is a problem on your assessment tonight. I would put 11 because I don't know how I got 10, or I don't know how the answer key got 10, but it just doesn't make sense to me. I don't know. It's a little bit weird. All right. Whew. I love those problems. I mean, those problems, they get easier as you do them, and we'll be doing a lot more of these problems this semester. I kind of enjoy them. All right, that is probably one of the hardest problems on the assessment tonight. I'm going to go in and open your assessment because you obviously know what you're doing, and we will see you back next week. It'll be Valentine's Day. You have a great one. Bye.